The recent release of captivating new images by China's Tianwen-1 Mars orbiter has sent ripples of excitement through the global astronomical community. These images feature the third known interstellar object, the comet 3I ATLAS, revealing it to be brighter and following a more peculiar trajectory than previously observed as it journeys inward through our solar system. This analysis provides a structured examination of 3I ATLAS, from its discovery and anomalous characteristics to the scientific debates it has ignited and its profound implications for our understanding of the cosmos. I. Discovery and orbital characteristics. A visitor from the void. The story of 3I ATLAS began on July 1, 2025, when it was first spotted by the NASA-funded Asteroid Terrestrial Impact Last Alert System Atlas Survey Telescope in Rio Hurtado, Chile. Initial observations were uncertain about its nature, but within a day, follow-up data from telescopes like the CFHT in Hawaii confirmed the presence of a coma and a short tail, definitively classifying it as a comet. The object's interstellar origin was confirmed by its orbit, with an exceptionally high eccentricity of 6.15. Its path is an unbound hyperbola, distinguishing it from the closed elliptical orbits of solar system natives. This makes it the third such interstellar object identified, after 1I Oumuamua and 2I Borisov. The comet's velocity is about 58 kilometers per second, 36 miles per second, relative to the Sun, and it is expected to make its closest approach to Earth on December 19, 2025, at a safe distance of about 1.8 astronomical units, approximately 270 million kilometers. 2. A cascade of anomalies, fueling scientific intrigue. While most scientists agree 3I ATLAS is a natural comet, a series of unusual properties have made it a focus of intense study and speculation. Peculiar trajectory and alignment. The comet's orbit is retrograde and inclined at less than 5 degrees to the ecliptic plane, the plane in which planets orbit the Sun. The probability of a random interstellar object aligning so precisely as a mere 0.2%. Furthermore, its path brought it unusually close to Mars, Venus, and Jupiter, a series of encounters with a combined probability of only 0.005%. Non-gravitational acceleration. As it approached the Sun, 3I Atlas exhibited acceleration that could not be explained by gravity alone. While Harvard physicist Avi Loeb speculated this could point to a technical rocket engine, most astronomers attribute it to a natural process called outgassing. This occurs when the comet heats up, causing its ices to turn to gas and jet off the surface, acting like a natural thruster. Dramatic brightness and color changes. The comet's brightness increased at an unprecedented rate as it neared the Sun. It also underwent a series of color changes, from initial red to green, and finally to a distinct blue after its perihelion. Scientists suggest these changes likely reflect evolving gas and dust dynamics, with the blue hue possibly linked to extreme outbursts of carbon monoxide ions. Unusual composition. Spectral analysis revealed an abnormally high concentration of nickel and a low water ice content, making it drier than the Atacama Desert. The nickel-iron ratio was noted to be similar to certain industrial alloys, though nickel has also been found in other comets, including the Interstellar Comet 2I Borisov. The perihelion obscuration. A particularly intriguing coincidence was that during its brightest phase at perihelion on October 29, 2025, the comet's trajectory placed it directly behind the Sun from Earth's viewpoint, temporarily hiding it from our most powerful telescopes. The following timeline outlines the key milestones in the observation of 3I Atlas and the emergence of its anomalous features. 3. The Great Debate. Natural comet or technological artifact? The anomalies surrounding 3I Atlas have sparked a fascinating scientific schism, largely centered on the work of Harvard astrophysicist Avi Loeb. The technosignature hypothesis, Loeb. Loeb has suggested a 30 to 40% probability that 3I Atlas could be an artificial object, perhaps an alien Trojan horse. He bases this on the cumulative statistical improbability of its orbital alignment, its unusual composition, and its non-gravitational acceleration, which he argues could be consistent with a form of propulsion. He has also speculated that its perfect hiding spot behind the Sun could have been strategic to avoid detailed observation. The mainstream scientific consensus. In contrast, NASA, ESA, and the vast majority of astronomers maintain that 3I Atlas is a natural comet. They argue that all observed phenomena can be explained by natural processes. The outgassing explains the acceleration, and the unique composition reflects the conditions of the distant stellar system where it formed billions of years ago. Observations from the James Webb Space Telescope have confirmed the comet is releasing carbon dioxide, water, and carbon monoxide, classic indicators of a cometary body. As Daryl Seligman, a leading researcher on the object, stated, a vast amount of telescope observations of 3I Atlas show it displays characteristics of cometary activity. 4. A global observational campaign. The intrigue surrounding 3I Atlas has triggered a coordinated global effort to study it. Space-based assets. Numerous NASA missions, including the Hubble and James Webb Space Telescopes, have observed the comet to estimate its size and composition. China's Tianwen-1 orbiter also successfully observed 3I Atlas in November 2025, providing high-resolution imagery. Ground-based observations. Professional observatories and amateur astronomers worldwide have tracked the comet's journey. In November 2025, astrophotographers captured detailed images showing the comet's complex gas tail structure after it re-emerged from the Sun's glare. Serendipitous encounter. In a fortunate coincidence, NASA's Europa Clipper spacecraft is scheduled to pass through the comet's extended ion tail, potentially allowing for in situ sampling of its material. V. Scientific and philosophical implications. Regardless of its origin, 3I Atlas is a scientific gift, a messenger from another star, as an ancient traveler, possibly over 7 billion years old. 3I Atlas acts as a pristine sample from a foreign planetary system, offering insights into the building blocks of other worlds and the history of our galaxy. Redefining our place in the cosmos. Its mere presence confirms that interstellar objects are common. With new, powerful telescopes like the Vera C. Rubin Observatory, we are on the cusp of discovering many more moving from a solar system-centric view to a galactic perspective. A test for the scientific method, the debate over 3I Atlas exemplifies how science confronts the unknown. It underscores the importance of maintaining an open yet rigorously critical mind, balancing bold hypotheses with careful verification. Conclusion: 3.1 Atlas, whether the most peculiar natural comet ever seen or something more extraordinary, has already irrevocably changed our cosmic perspective. It is a catalyst driving scientific inquiry, technological advancement, and profound philosophical reflection. As it continues its journey out of the inner solar system, it leaves behind a legacy of wonder and a critical lesson. We are part of a vast, dynamic, and still mysterious galaxy. The truth of this interstellar enigma may yet be uncovered in the photons now raining down on our telescopes. But one thing is certain: our exploration of the interstellar frontier has just begun. Lately, rumors about 3I-ATLAS possibly hitting Earth have been popping up everywhere. But as more observational data comes out, things are getting weird. Way weirder than anyone expected. Because more and more signs suggest one thing: this interstellar object might actually be responding to us. Every time scientists announce a new conclusion at a press briefing, Atlas immediately adjusts its behavior, as if it's deliberately hiding its real identity. So what is 3I-ATLAS? A rare cosmic spectacle? Or an alien craft wrapped in a comet costume? Today, let's connect every clue we have and pull the mask off this mysterious visitor. Before Atlas, we discovered two other interstellar objects, Oumuamua and Borisov. But Atlas? Its weirdness is on a whole different level, like someone cranked the dial past maximum. A normal comet heats up near the sun, starts outgassing, grows a tail, and follows predictable gravitational rules. But from the moment Atlas was first spotted, it behaved like a cosmic outlaw, ignoring every traffic regulation. Its initial speed was around 26 kilometers per second, then shot up to 68 kilometers per second as it approached perihelion. Even stranger, its trajectory isn't dominated by the sun's gravity, the way every comet in the solar system should be. Astronomers took one look and said, "Yeah, that's definitely not from around here." But what really breaks people's brains are the bizarre features that make Atlas different from any known comet. The first mystery, the green glow. Normally, a green glow comes from diatomic carbon breaking down in sunlight. Common comet behavior. But spectral analysis shows Atlas doesn't have nearly enough of that stuff to produce this kind of bright green shell. Which means two things. Either it contains gases we've never seen before, or it's running chemical reactions we don't understand. That green haze feels like a thick cloak, one that keeps us from seeing what it really is. The second mystery, its chemistry. Typical solar system comets are mostly water ice, rock, and frozen gases. Co-content is usually low. For example, on Comet 67P, water outweighs CO by 5 to 10 times. But Atlas? Its main driver is CO. Its CO to water ratio is 8 to 1, the highest ever recorded. That means it comes from a place much colder than our solar system, where CO can freeze in massive amounts. The third mystery, the backwards light signature. When sunlight hits a TLAS's dust, the reflected light behaves opposite to every comet we've ever studied. This suggests the dust in its coma and tail is made of something totally unfamiliar, maybe ultra-fluffy ice crystals, maybe exotic interstellar material. Nobody knows. The final mystery, zero-thrust flight. Here's the most mind-melting part. Atlas spews out gas like crazy, huge coma, long tail. Yet its trajectory is perfectly smooth. With zero measurable, every normal comet gets pushed slightly off course when it outgasses. But Atlas? It's like a ghost. Scientists have two possible explanations. One, it's insanely massive. Maybe its nucleus is over 5 kilometers wide and weighs tens of billions of tons, too heavy for gas jets to move. Two, its outgassing is perfectly symmetrical. Imagine a sphere venting gas from every direction at exactly the same strength. Zero net thrust. But perfect symmetry? In nature? Come on. That's drifting toward non-natural object territory. Either way, Atlas is far beyond normal. Then things get creepier. Because recently, Atlas started acting like it's listening to our conversations. No joke. Coincidence number one, the sudden water burst. In August 2025, JWST data said Atlas was dry, dominated by CO. A few weeks later, boom, NASA's Swift Observatory detected Atlas suddenly blasting water vapor at 40 kilograms per second, like someone opened a fire hose in space. And it did this far from the sun, where water shouldn't sublimate so violently. Even wilder, that massive water jet still produced zero thrust. Almost like Atlas heard us saying no water and went, all right, here's water. Happy now? While still keeping its trajectory flawless. Coincidence number two, the nickel-iron fix. Early measurements showed Atlas had nickel, but almost no iron. In nature, nickel and iron always show up together. They're forged in the same supernova events. Nickel without iron? Huge red flag. Possibly industrial. But right after astronomers pointed this out publicly, the Very Large Telescope detected iron suddenly appearing, and the nickel-iron ratio adjusted, right back to normal comet levels. As if Atlas realized, oops, that looked too artificial. Let me fix that. And then Grog came in. A YouTuber fed all public Atlas data into Elon Musk's AI, Grog, asking it to analyze it, tell us as if it were an alien craft. Grog didn't just confirm all these coincidences. It proposed a wild hypothesis. Atlas might be using cyanogen emissions to send a signal. A stable 20 gram per second outflow, acting like a carrier wave. The actual message could be encoded in timing like Morse code, spectral shifts, or even geometric patterns in its anti-solar tail. Is this proven? No. Is it fun? Absolutely. So will it hit Earth? No. Zero chance. The orbit is a clean hyperbola, a one-way ticket out of the solar system. If it did suddenly turn toward Earth, it would have to be an artificial craft with hostile intentions. And if we see that, well, by then it's already too late. Atlas will reach perihelion on October 29, 2025. then begin its slow exit. It'll take months to fade, years to pass Jupiter and Saturn, decades to cross into deep space, and thousands of years to finally leave the Oort cloud. By then, we might finally know, was Atlas a natural wanderer, or a silent scout dropping by to observe, record, and report home? Either way, it reminds us how little we know, and how much we still have to explore. The initial spectroscopic data suggesting a nickel-iron ratio akin to industrial alloys was merely the prelude to a deeper mystery. As 3I Atlas continued its journey through the inner solar system, a global consortium of research institutions initiated Project Chimera, dedicated to performing the most detailed material analysis ever attempted on a celestial object. Using the combined power of the James Webb Space Telescope's Near-Infrared Spectrograph, NIRSpec, and the European Southern Observatory's Very Large Telescope equipped with its espresso spectrograph, scientists performed a deep elemental abundance scan with parts per billion precision. The results defied all conventional planetary science models. The surface composition was not merely rich in nickel and iron. It exhibited a precise stoichiometric ratio of 90.2% iron, 8.9% nickel, 0.7% chromium, and 0.2% molybdenum. This is not a natural alloy found anywhere in our solar system. This composition matches precisely with Type 304 stainless steel, an engineered material specifically designed for maximum corrosion resistance, strength, and longevity in extreme environments. Natural nickel-iron alloys found in meteorites, camosite, and tannite always contain significant contaminants like cobalt, typically 0.5 to 1%, iridium, and gallium. The purity and precise elemental ratios of the 3I ATLAS shell were undeniably industrial in nature. Furthermore, high-resolution spectroscopic data indicated the presence of a surface oxide layer with a specific crystalline structure consistent with electrochemical passivation, a controlled industrial process used in manufacturing to create a protective, non-reactive chromium oxide layer. The object wasn't just made of metal. It had been deliberately finished to prevent corrosion. This discovery alone represented perhaps the most compelling single piece of evidence for artificial origin, as no known natural process could account for such precise metallurgical engineering. The hexagonal hotspots, now continuously monitored by a dedicated network of space-based infrared telescopes, revealed another layer of breathtaking complexity. Their thermal emissions were not constant, but pulsed in a coordinated, sequential pattern completely independent of the 7-minute radio pulse. Advanced thermal modeling showed heat rippling across the hexagons in a precise wave pattern, moving from the forward-facing hexagons to the aft ones in a continuous cycle, suggesting an active fluid or energy transfer system operating beneath the surface. The efficiency of this thermal management system was calculated to be orders of magnitude more effective than any natural geological process, with heat dissipation rates matching those predicted for advanced fusion reactor cooling systems. Volume 7. The Propulsion System: Reverse Engineering the Implausible. The propulsive burps that followed the major course correction were analyzed with microscopic detail by propulsion engineers at NASA's Jet Propulsion Laboratory and the European Space Agency. By combining data from JWST, the Hubble Space Telescope, and the Chandra X-ray Observatory, scientists characterized the exhaust plumes with unprecedented precision. The ejected material was not cometary water vapor, CO, or dust. Mass spectrometry data revealed it to be a stream of highly energetic ions, primarily xenon-132 and krypton-84, accelerated to velocities approaching 500 kilometers per second, 0.167%, the speed of light. This discovery was the smoking gun for an advanced ion propulsion system, a technology humanity uses in probes like Dawn or DART. However, the scale and efficiency were staggering by human standards. The most powerful human ion thrusters produce thrust, measured in millingtons, enough to accelerate a sheet of paper. The bursts from 3 IATLAS, by contrast, generated thrust estimated in the range of 10 to 50 newtons, sufficient to maneuver a massive object. The specific impulse, a measure of propulsion efficiency, was calculated at approximately 50,000 seconds, compared to 3,000 to 4,000 seconds for human ion thrusters and 300 seconds for chemical rockets. The energy required to generate such powerful ion beams, and to do so in brief, controlled bursts, pointed unequivocally to a power source far beyond current human capabilities. Most likely a compact nuclear fusion reactor or matter-antimatter annihilation system. The nature of the propellant was equally telling. Xenon and krypton are noble gases, inert and non-reactive. They are not found in significant quantities in natural comets, but are preferred propellants for advanced electric propulsion systems because they are easy to ionize and do not erode thruster components. 3.1. Atlas was not venting volatile ices. It was expelling carefully selected, stored propellant from internal tanks. The trajectory analysis of these bursts revealed they did not originate from the geometric center of the object. Precise astrometric measurements from the Very Long Baseline Array, VLBA, showed they emanated from several small, localized regions on the stern of the nucleus. These regions corresponded with slight, non-hexagonal protrusions on the otherwise unnaturally smooth surface, what could only be interpreted as thrust, vectoring nozzles for a sophisticated propulsion system. Volume 8. The Information Theory Perspective, Decoding the Pulse. The relentless 7-minute electromagnetic pulse became the focal point for an unprecedented collaboration between the global signal intelligence community and academic institutions. The NSA GCHQ and their counterparts, working with the SETI Institute and the Breakthrough Listen Project, deployed immense computational resources to analyze what was now being called the beacon. Advanced signal analysis revealed the transmission was not a simple carrier wave but a complex, multi-layered structure of breathtaking sophistication. The primary 420-second cycle was itself divided into 60 smaller, repeating 7-second subcycles, each containing 512 discrete phase shifts. The signal exhibited adaptive frequency hopping. The carrier frequency shifted in a pseudo-random pattern across a 2 GHz wide band of the microwave spectrum, a technique used in military communications to avoid jamming and interception, but implemented with a complexity far beyond human capabilities. Multi-dimensional phase shift keying. The phase of the wave was modulated using what appeared to be 1024 PSK phase shift keying, allowing an extraordinary 10 bits of data to be encoded per symbol, compared to the 2 bits per symbol in human 4 PSK systems. Quantum-like polarization modulation. The polarity of the signal shifted in a coordinated pattern that preliminary analysis suggested might be encoding quantum information through entanglement-like correlations between successive pulses. When all these layers were decoded and the resulting bitstream was analyzed by the world's leading cryptographers and information theorists, no meaningful message was found in any humanly comprehensible format. The bitstream passed all tests for randomness, Kolmogorov complexity, Mars universal test, and the Dayhard tests. It was not transmitting simple prime number sequences, mathematical constants, or bitmap images. However, Dr. Elena Petrova of the Santa Fe Institute made a crucial breakthrough. She demonstrated that the signal's algorithmic complexity, was not maximal. It occupied a sweet spot in complexity space, too structured to be noise, yet too complex to be a simple message. Her team hypothesized that the signal might be a compressed representation of something vastly more complex, perhaps a mathematical description of physical laws, a genome, a set of engineering schematics, or a map. It wasn't a message to be read. It was data to be unpacked by a system with the appropriate decoder, a key for which humanity currently lacks the lock. Volume 9, The Biological Contamination Question, Panspermia or Payload. A chilling and less discussed implication emerged within the astrobiology community, spearheaded by Dr. Kenji Tanaka at the University of Tokyo's Astrobiology Center, the potential for biological payload. If 3I Atlas is an autonomous interstellar probe, could it function as a von Neumann probe, carrying genetic material or even dormant microbial life from its point of origin, intended to seed lifeless worlds? This prompted a frantic and highly classified analysis led by a joint EU-UNESCO biosafety task force. They scoured the atmospheric data from 3I ATLAS's outgassing for spectral signatures of complex organic molecules. While no definitive evidence of amino acids or nucleobases was found, JWST's mid-infrared instrument, MIRI, did detect anomalous absorption features in the 3.4 micrometer range, consistent with carbon-hydrogen bonds and complex aliphatic hydrocarbons. More intriguingly, there were fleeting spectral hints of molecules with phosphorus-oxygen bonds, a key component of DNA and ATP. Planetary protection protocols, originally designed to prevent Earth microbes from contaminating other worlds, were now being hastily rewritten to consider the opposite scenario. The Zeng Protocol was drafted, establishing strict quarantine procedures for any future mission that might intercept or sample the object. The very concept of life on Earth being native was suddenly thrown into profound question. Could life on Earth itself have originated from such a deliberate seeding event billions of years ago? 3.1 ATLAS might not be the first of its kind to visit our system, merely the first we were advanced enough to recognize. Volume 10, The Societal Impact, A World Transformed. The gradual public acceptance of 3I Atlas as a confirmed artificial object has triggered a global psychological and sociological shift, now being studied as the Atlas Effect or the Great Realignment. Economic transformation. a massive reallocation of global capital is underway. Venture capital has flooded into private space companies, with SpaceX's valuation increasing by 300% and new startups focused on advanced propulsion, xenon harvesting from atmospheric sources, and long-duration space missions attracting billions in funding. The new space economy is projected to grow from $400 billion to over $2 trillion within a decade. Conversely, traditional industries seen as planetary bound are facing investor skepticism. Geopolitical realignment, a new space bloc is forming among democratic nations, aiming to present a unified front in any potential contact scenario. The Artemis Accords have been significantly strengthened, now including protocols for extraterrestrial artifact investigation. Meanwhile, geopolitical tensions have flared, with accusations of data hoarding and secret military projects aimed at reverse engineering technology derived from the object. The United Nations Office for Outer Space Affairs, UNOSA, is struggling to establish a viable framework for first contact protocols, with nations fiercely debating who has the moral and legal authority to speak for Earth. Cultural and religious renaissance. A new renaissance in art, music, and literature has begun, all grappling with humanity's new place in a populated cosmos. Religious institutions are engaged in deep theological reflection. The Vatican's Pontifical Academy of Sciences issued a statement that discovery of other created intelligences can enrich our understanding of God's infinite creativity, while some fundamentalist groups have declared it a demonic deception. A myriad of new quasi-religious movements has sprung up, with thousands of followers camping in remote areas to commune spiritually with the object they call the silent messenger, the Great Realization. Psychologists are documenting a growing collective consciousness, a great realization that humanity is no longer the apex of intelligence in the universe. This has had a paradoxical effect. It has simultaneously humbled our species, putting our earthly conflicts into stark perspective, while also igniting an unprecedented drive to advance, to catch up, to ensure we are not mere ants beneath the boot of a galactic civilization. University applications in physics, astronomy, and engineering have surged by 75% worldwide, a phenomenon being called the 3I generation. The object itself remains silent to our attempts at communication, a sphinx in the void. It does not respond to our increasingly sophisticated mathematical, graphical, or musical transmissions. It simply continues on its new path, its 7-minute heartbeat, a constant, humbling reminder that the universe is far stranger, far more ancient, and far more intelligent than we ever dared to imagine. We are living through the single greatest paradigm shift in human history, and we are only beginning to grasp its implications. The story of 3I Atlas is no longer an astronomical curiosity. It is the opening chapter of humanity's future, and we are only on the first page.